Welcome to the discussion and thank you for always joining us. We are presenting a question that was done in K.c.s.e 1999, paper 1 question number 19, a question on angled properties of a circle. And the question we have reads, the figure below shows two circles APQ and ABS are intersecting at A and B. PBS, QART and ABU are straight lines. The line UST is a tangent to the circle ABSR at S. Angle BPQ is 80 degrees, PBU 115 degrees and BUS 70 degrees. Find the values of the angles, stating reasons in each case. We want to start by looking at the diagram. In the figure we have, you realize PBAQ is a cyclic quadrilateral, and therefore the opposite angles of a cyclic quadrilateral will add up to 180. So if the angle at this point is 80, then the angle here is 100, and also the angle at this point is going to be 80 degrees, since angles on a straight line add up to 180 degrees. We move to this other angle at point B. Remember, we have 115 at this point, meaning if we extend this line, we are going to have a straight line angle. 115 from 180, you get 65 degrees. And if this is 65, we are going to have 65 degrees at this point, because these are vertically opposite angles. Then if that is the case, then we are going to have 115 at this point, because again, this angle here and this angle form the opposite angles of a cyclic quadrilateral, which is going to give us 115 degrees. If that is the case, again, we can move forward and get other angles. We already know that the angle at this point is 70, and the angle at this point is going to be 65, such that 70 plus 65 will give us 70 plus 65 gives us 135, and therefore from 180 we are going to have 45 degrees at this point here. Again, once we have done that, we can proceed. Remember, this angle at this point here is the vertically opposite of this angle here. We are going to have 115 degrees. That means the angle at this point is going to be 65 degrees. And if that is the case, then the angle here is going to be 115 degrees. But we can simply, so this one is going to be 115 degrees at this point. We can as well get this angle here, which is going to be 100, because the angle at A and the angle at S forms the opposite angles of a cyclic quadrilateral. Having done that, we can now move. Remember, at S we have a tangent, meaning if you take 45 plus 100, you minus from 180, we are going to have 35 degrees at this point here. And if that is the case, then the angle at point T here is going to be 115 plus 35. 115 plus 35 will give us 150, meaning the angle at T is going to be 30 degrees. I think we have done most of that. We can now go and start getting the sizes of angle BAR. BAR, BAR AR is going to be 80 degrees. BAR is 80 degrees since angles on a straight line add up to 180 degrees. Angles on a straight line add up to 180 degrees. Then we have angle STR. STR will be 30 degrees. We have used some angles of a triangle. Some angles of a triangle add up to 180 degrees. Then we go and get BSU. BSU is 45 degrees. Again, we are going to use the property of some angles of a triangle, because that is what we have used. Some angles of a triangle add up to 180 degrees. Then we have BRS. BRS, we are going to divide this angle into 2 by joining B and R, and then get the size of that angle, and then get the size of angle BRS, which is going to be the alternate angle of the angle at this point S. This one is going to be 45 degrees. So this is also going to be 45 degrees. So the answer we give is that angles in alternate segment are equal. That is the solution to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. And for those who are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.